Good morning, AP Bio. Here we go. Hopefully you enjoyed yesterday's TED Talk. When last we were talking science that was not just practicing AP exams, we were talking about how things evolve. And we had just left you with the Hardy-Weinberg equation. Now that's a little over a week ago. And as bright as you are teenagers, and your whole goal in life is to try and forget everything you learn the minute you learn it. And particularly after you apply it to an exam and you're done with it for life. Anyhow, so simple, ease back into work today. I have this Hardy-Weinberg little kind of work packet for you to go through and answer. And really all it'll do is it'll work you again through the concept of species population and eventually get you into the math. P squared 2pq and the q squared, and have you do some calculations. So while it looks like it's a lot of stuff, it actually goes pretty quick. I would believe that you can have this completed to upload by sometime on Thursday. And then I'm going to set you up for the weekend with an activity, again, kind of related to populations, but more on the Hardy-Weinberg and how do they shift. How do population allele frequencies change and shift, genetic drift, and some things along that line. And to do that activity, if we were in the class, it'd be no problem because I have two big tubs of dried beans, one white bean and one a dark colored, it's not black beans, it's a brown bean. It might be a pinto bean or something, or just whatever. Anyhow, what you will need at home, and I don't mean you have to go out and buy bags of dried beans that you'll never use. I mean, hopefully you can find something. What you need are two different colors, because essentially what the beans are representing are two different alleles. So before you get to the weekend in that activity, and you need 50 of each. Really is it. Well, actually probably a little more than 50 of each, because as you see when you do things, once your allele frequency starts shifting, what you're doing is you're having 50 of each to have an initial total population of 100 alleles, 50 sets, 50 type of each color. And then as things shift, then you have to go that way. So if you do have a couple of different bags of dried beans at home, you're probably good. If you don't, I have faith that even though you're goofy teenagers who always try and forget everything the minute you learn it right after the exam, that you can find a way to find a bunch of two different somethings, small little somethings that you can count as alleles and separate. But anyhow, I'll give you that preview a little bit beforehand. Like I said, in class we'd use beans, but and really it's just because it's a very good exercise and actually hands-on seeing the shift in allele frequencies that can happen in a normal population. Anyhow, long-winded, way too long-winded a deal. Just work on Hardy-Weinberg in the packet and be able to do those calculations, because they are key to doing some of the Hardy-Weinberg lab shifts. Anyhow, there we go. That's it. Have fun with the packet. We will talk to you later.